All right, let's look at linear functions. Let's say, so here's the definition. A function f from Rn to Rm is called linear if two conditions. First one, f of v1 plus v2 is equal to f of v1 plus f of v2. Right, so you basically can apply f to each one and then add them up later. All right, and f of k times v, you can pull out the k, so it's a k times f of v. For all vectors v1, v2, v, and a scalar value k. All right, so let's look at a couple of simple examples here. All right, so here, let's say you have a function f, and so it's R2 to R, so it's a scalar valued function defined on R2. And let's say definition is f of x comma y is equal to 2x minus 3y. And it looks linear, so let's double check. All right, so let's look at the first condition. All right, so if you have f of, all right, so I have to two vectors. I'm going to call first vector x1 comma y1, about that. And plus second vector would be x2 comma y2. All right, so this is simply the same thing as we basically add the x components together. So x1 plus x2 comma y components together, y1 plus y2. All right, then if you apply the definition, so 2 times the first component, so it's a 2 times quantity x1 plus x2, minus 3 times the second component, which is y1 plus y2. All right, then you can, distribute 2 to both of these guys, and I'll probably write it as, right, 2x1 and also 2x2. I'm going to rearrange 2. All right, then I'm going to distribute the negative 3 to both of these terms. So you have minus 3y1 and minus 3y2. All right, then you can see that we can group these things together. All right. And you see that the first grouping is exactly the same thing as f of x1. And the second grouping is, actually, I messed that up. F of x1 comma y1. And the second grouping is f of x2 comma y2. All right, so which verifies the first condition. All right, how about the second condition? So 2, it's kind of a tedious checking. So f of k times, let's just say x comma y. All right, so it's just, this is the same thing as apply k to both components, kx comma ky, then apply the definition. So it's 2 times the first component, minus 3 times the second component. All right, but you can see that the k is in common. So we can pull that guy out. So we have k times 2x minus 3y. But as you can see, 2x minus 3y is exactly the definition of f of x comma y. All right, so this verifies the second condition. So therefore, this guy is definitely linear. All right. How about the second one? All right. So this is going to be a vector valued function. So it's R2 to R2. All right, capital F of x comma y. So I decided to use a capital F since it's a vector valued function. And the first component is 2x plus 1, but it looks linear. And 3y looks linear too. All right, let's check. The first one, All right. I might just do the first one. So we're gonna do f of. Actually, why don't we do the second one? Second one might be easier. All right. So I'm too lazy. All right. So let's try this. All right. So if you look at the f of capital F of k times x comma y. Let's try that. See what we can get. All right. So this is going to be equal to. All right, so it's going to be kx comma ky as usual. All right, then you end up getting a vector. So you have a 2 times the first component plus 1, and 3 times the second component, ky. All right, so we get that. All right. And let's try to find the k times f of x comma y separately, right? So this is going to be k times, right? By definition, this is just a 2x plus 1 is the first component, and the 3y is the second component. Then you can distribute k to both components. Right, then you end up getting this. You have a 2kx plus k and a 3ky. Right? Do they match up? All right, so you can see that the second component, there's no issue there. Right, but you can see that here 2kx plus 1 isn't quite the same as 2kx times k, unless I guess k equals 1, but the k should be any random number, so they're not in general the same thing. So it actually fails the second condition already, so we know that this one is actually non-linear. Right? So the second example looks like it's linear, but if you check it, it's not a linear function. All right. So this is linear functions, and the textbook define it the scalar valued function and the vector valued function. I did it in one shot, but I hope there was no confusion there. All right, that's it. I hope that this was clear.